All right, moving on to questions concerning confidence intervals for proportions. Okay, so in a recent survey, 59 young adults, 31 reported having voted in the previous election. Construct a 95% confidence interval for the portion who voted. So at this point, you should go ahead and pull out your formula sheet. Look for on the back of the formula sheet. There's all these formulas for confidence intervals. So you're going to need to know how to use these. Okay. Now we're talking about confidence interval for proportion, so it's these formulas here. So I'm going to go ahead and copy these onto my document I have here. So I know I'm doing a confidence interval for proportion. It tells me to find a confidence interval for proportion. So I'm going to be using these formulas. Okay, and then it's just kind of a matter of figuring out which each of these pieces are, plugging them in, and solving. Okay, so starting with p hat. P hat is your sample proportion. So in my sample, I have 31 who reported voting out of 59. Okay, I'll go ahead and leave that as a fraction for right now. Okay, I also need to know what's q hat. Q hat, remember, is always 1 minus p hat. So if you do 1 minus p hat, you should get 28 out of 59. Okay, our sample size is 59. Alright, z alpha divided by 2. Now this is purely defined by the fact that we are doing a 95% confidence interval. Okay, so we're doing a 95% confidence interval. Let me draw this up here. Which means in the center I have 0.95, on each tail 0.025, 0.025. Okay, so if I look up in my table, this area back here would be 0.975, right? 0.95 plus 0.025. So 95 is in the center there. Okay, so if I go to my z table, alright, and I look up 0.975, there it is right there, that's 1.96, okay? So it turns out that that's always going to be z alpha divided by 2 every time you're doing a 95% confidence interval, which is the most common type of confidence interval. So there's actually a little cheat sheet down here. It says for 95%, this is the critical value, 1.96. Okay, you still need to know how to calculate it. I'll do an example in a minute where I don't think it's one of these listed ones, so you have to know how to calculate it. Alright, so 1.96. Alright, so now I have all the pieces. I can calculate E. Z alpha divided by 2, which is 1.96, square root of 31 over 59 times 28 over 59 all over 59. Okay, try not to do any rounding until you're plugging it into your calculator. So I'm going to go ahead and plug it in all at once. I'll show you how I do it. So I do 1.96 times the square root. Okay, I'm going to use parentheses for my numerator. So 31 divided by 59 times 28 divided by 59. Okay, so that's closes the parentheses on the numerator. And then divide that by 59. Okay, and then I close the parentheses for the square root. Remember, for the square root, there was an open parentheses there. Yep. Okay, press enter. So that's my E value. Okay. Round that to 4 decimal places. Alright, so 31 divided by 59 in terms of a decimal is 0.5254. So then when I'm calculating this, my confidence interval, I'll do 0.5, actually I'm going to go ahead and do my calculator. So I'll do 0.5254, subtract off the margin of error. Okay, that'll be my lower bound. 0.3980. Okay, do the same thing with addition. That'll be my upper bound. Okay, so that's my 95% confidence interval. All right, based off of that interval, is it reasonable that the true percentage of young adults that voted is 50%? So this is an interpretation of your confidence interval. In addition to being able to calculate a confidence interval, you should know a little bit about how to interpret it. All right, so what this is saying is that we are 95% confident that the true proportion of young adults that voted is between 0.398 and 0.6528. Okay, so could it be 50%? Yeah, of course it could be 50% because 50% is inside of our interval. So yes, because 50% is inside our 95% confidence interval. Okay, so it appears reasonable. It could be 50%. It could be any number in this interval. Could it be 75%? Well, we're 95% confident that it's not 75%. Because 75% is not in our interval. Okay. A researcher wants to estimate the percentage of people married at 25 years old. Pollster, or the researcher, wants to be 95% confident that the estimate is within 2 percentage points of the truth. Okay, assume there's no prior estimate of the percentage available. Okay, let's go to back to our formula sheet. This question is asking, notice he's asking how many people should be included in the poll. That is a sample size type question. They're trying to ask how many people you should sample. Okay, sample size for proportion, the portion of people who are married, right? That's what he wants. That's what the researcher wants to know. So let me go ahead and copy that formula down. All right. Okay. So this is the portion. There's another one for portion. It says when P and Q are known, when estimates are known. All right, and this one says assume no prior estimate is available. So we're going to use that first formula first. Okay, let's see. The pollster wants to be 95% confident. So that Z alpha divided by 2, it's going to be the same as this Z alpha divided by 2 here. It's going to be that 1.96. Alright, E is your margin of error. Now, he wants to be correct within 2 percentage points of the truth. 2 percentage points. Does that mean E equals 2? No, that's the most common mistake. Remember, you have to change that into a percentage, that 2. Has a percentage that is 0.02. 2 percentage points, right? 2% is the same thing as 0.02. Okay, once you have that, go ahead and plug that into your calculator. Okay, 1.96 times 0.25 divided by 0.02 squared. Okay, this one comes out to a whole number, right, that rarely ever happens. Alright, usually it comes to a decimal and you round up. Because you can't have 0.1 of a person or 0.02 of a person. So you always round up your estimate. But since this comes to an exact number, that should be our minimum sample size. Alright, let's do another one where assuming prior studies showed that 41% are married, so how many people should be included given that information? So now we use the other equation. Okay, Z alpha divided by 2 is the same. Now P hat is that 0.14. Now Q hat is always 1 minus P hat. So 1 minus 0.14 is 0.59. E stays the same. Okay, so now you're ready to do that. Plug that into your calculator. 1.96 squared. Okay, so now you get 2323.21. Now you can't have 0.21 of a person, so sample size calculations, you always round up to the next person. So you need at least 2,324 people. Alright, now finding the z alpha by 2 for a 85% confidence interval. Okay, so you should know how to find these z's, these critical values for any type of confidence interval. Okay, so in this case, 85 is in the middle, which leaves how much for the tails, right? The entire thing is 1, right? So 1 minus 0.85. So 15 for the tails. Now, you have 2 tails, you need to divide that in 2. So 0.075 for each tail. Okay, so 0.85 plus 0.075. So the area behind this, here and back, is 0.925. Okay, so if I want to find this cutoff, I need to find that corresponding area. So I go to my z table. Okay, I'm looking for 0.925. Right. So that's the closest value. It's only 0.0001 away. 1.44. Okay. So most of the time the critical values are given to you down here for common confidence intervals, but sometimes you do need to calculate out, and you should know how to calculate z alpha by 2 for any type of confidence interval. Okay. Suppose a 95% confidence interval for a proportion is 0.65 to 0.75. Find the margin of error. Okay. So this one is the type of question where you kind of have to think backwards. Alright, now you know the sample proportion. Remember when we calculate our confidence interval, we go E below and E above the sample proportion. So we know the sample proportion is directly between those two numbers. Now how do you find a number that's directly between two endpoints? You add them up, basically average them, and divide by 2. Alright. Point 0.7. Oh, well, that's the sample proportion. Okay, so how much did I go up from 0.7 to get to 0.75, and how much did I go down from 0.7 to get to 0.65? Right? So 0.75 minus 0.7 is 0.05, and 0.7 minus 0.65 is 0.05. So I'm basically going the margin of error below the sample proportion and the margin of error above the sample proportion. So my margin of error must be 0.05. All right.